Hello and welcome back. So today we are going to talk about engineering mechanics and we are going to focus on statics. So we have a problem about a truss. Here is a problem. You can zoom in. Okay, so you can see. Okay, so here is a problem. We are going to assume that there is a load here acted on F, which is typical of like the weight of a motor or anything that hangs from the hanger, like 10 kilonewton, and we need to find the reaction forces. Okay, so first we'll choose joint F and we will choose the joint method. We are going to solve this problem using the joint method. Okay, we are going to draw our axis. Okay, X and Y. Okay, here we have a horizontal force which is force dF. Also we have here force with an angle which is called FEF. Okay, we need to solve this force into horizontal and vertical forces. Okay, so first of all, here is a 10 kilonewton force, and here is the force. I assumed this. Maybe force FDF is in the opposite direction, but we will see. We will see the value. Here is FDF, and I need to solve this into horizontal and vertical. Here we have an angle theta. This angle, if you calculate it, it will give you 63 from the horizontal, 63.4 degree. Okay, so here we have force EF sine 63.4. Someone might ask why we say this sine and the other one here is cosine. Yes, so this is trigonometry. So here we have, this is the horizontal and this is the hypotenuse and this is the angle theta. Okay, so the opposite is sine, right? And the adjacent is cosine. So that's why I choose this sine and this one is cosine. Okay, so this is our joint. So when we of course solve our problem in static equilibrium, right? Okay, so we will say summation of forces in y direction equals 0, and then we will say that 10 kilonewton equals this value, right? So we will find force EF. Force EF equals 0.75 Newton. Okay. Also, we will say summation forces in the x direction. summation of forces x. Okay, we are back again. So we were talking about summation forces in the x direction equals 0. So here FDF plus, so force df plus this value equals 0. We already have force in the EF direction, so therefore force df will be equal to 5000 7.6 Newton. Alright, so we got our values, force df, okay, and force EF. Okay, so here someone might ask me why we choose this and this joint F, why we didn't choose like joint D, and uh, that's a tricky one, because here you will have a lot of unknowns. So let's see, you will have here force D E, and here force T F, and here force B D, and here force C D. So you have like 1 2 3 4 unknowns, and you don't know, like the known value is like there's nothing, so it's impossible to solve it. So that's why we choose this joint, because it has a known value and it can be solvable. So when you switch to this joint, to this joint, you can now solve it, and so on. You can switch to this one, and then this one, and then this one, and then this one, and then this one, until you solve the whole truss. Okay, so I want to show you it can be solvable. So you need to remember these values. Okay, we actually put this our joints and our links in a software, and it automatically computes the force here and here. This is the resultant force. This is in F force FDF 5000, and here we calculate it like 5000, and here force FE, which is 1800, and here it is. It automatically calculates it. What's more like genuine about software is that it can, when you choose another body diagram, it can automatically, without like taking calculations like what we do in manual calculation, it will automatically calculate it, and it will get you the values. Here are the values. These are 3 links, and here we got the 4th link. This is the value, the 5th, and so on, until you solve for the problem. Okay, so it's a really beautiful software, and in the next video we will also take like another static problem, and we will see how we can get the values from the static problem using the software. Okay, thanks for your time.